Welcome to the Consciousness Physics lecture series. This is lecture 3rd. We are going to look at cylindrical coordinate system in this lecture. So this is the mathematical physics lecture 3rd. Okay, so let's recap what we have done last time. So if there is a vector r in the r cap direction, there's a vector, it has an x component and also a y component. It has an angle theta with the x-axis. So in the Cartesian coordinate system, we can represent this in vector r must be equal to rx in the x cap direction plus ry in the y cap direction. In polar coordinate system, vector r must be equal to r r cos theta in the x cap direction plus r sin theta in the y cap direction. And in spherical polar coordinates, and we are expanding this lecture in this vector into 3 dimensions, so r must be equal to r sin theta cos phi in the x cap direction plus r sin theta sin phi in the y cap direction plus r cos theta in the z cap direction. So this is the vector representation in 3 dimensions for spherical polar coordinate system. So this is exactly what we have done last time. Now let's look at cylindrical coordinate system. So what is a cylinder? So a cylinder is the basis of a cylindrical coordinate system. So cylinder will have a cylinder have a shape, and it has a radius and a length L, right? So that's the basic structure of a cylinder, and these are the coordinates of a cylinder. Now let's construct a cylinder in 3 dimensions. So using x, y and z axis, you can construct a cylinder by moving from the origin an r length, right? R length in the r cap direction from 0 to r, right? You're moving from origin, and then you move in the phi cap direction, because in the right-handed coordinate system, phi cap direction is from the x-axis. So in the phi cap direction, you move from 0 to 2 pi, so it becomes a complete circle, right? So it becomes a complete disk of space. And in the z cap direction, you move from 0 to L, right? 0 to L, and you get a solid sphere. Now let's do this again, because I'm doing this again to make sure that you understand the concept. So let's construct a cylinder for cylindrical coordinate system again. Now what first thing that you will do is that you will see the shape of a cylinder. Cylinder will have a radius r and a length L. So that's the basic shape of a cylinder. Now what we'll do is that we will look into the 3-dimensional axis x, y and z in the right-handed coordinate system. And what we will do is that from the origin, we move in the r cap direction from 0 to a radius r, a fixed radius r, to construct the first part of constructing a cylinder. Then in the phi cap direction from x-axis, right, you move from 0 to 2 pi. So you get a complete disk of space, right? That's the disk you form. And then in the z cap direction, you move from 0 to L, right? So from 0 to L, you move up and you get a disk transformed into a solid cylinder. So this is the structure that you got. So let's now look at the cylindrical coordinate system and find out the actual cylindrical coordinates, right? So we have a vector r, which is the radius, and phi, which is the angle from the x-axis using right-handed system. We recreate that. The vector r and phi, you can see that r will have x component rx and y component ry. Simple. So rx must be equal to, using trigonometry, r cos theta, right? Magnitude of r times cos phi. And ry must be equal to r sin phi, right? Simple. And so, and also in the z cap direction, the change is in the z cap and there is no phi dependence. So it's just z. Now you can see that magnitude of r must be equal to square root of x square plus y square, rx square plus ry square. So that will be that. And ry by rx you can divide and you get tan phi, right? So phi must be equal to tan inverse ry by rx. So rr cancels. So that's the total system, coordinate system. Let's now look at the infinitesimal change in the dl, dv and dA for the cylindrical coordinate system. So what will be the volume, area and length change, right? Small changes. So for that, let's consider a vector, right? A vector dl change given to a vector r in the r cap, phi cap and z cap direction. So dl is added, so it will become a new vector is in the r plus dr, phi plus d phi and z plus dz, like elemental changes will be added. So the dl will be having components in the r cap directions, phi cap directions, and also in the z cap direction. So this will be the change in the dl. So to calculate that, let's consider a vector r, right, vector r, and add a dr element to it, right, dr element, elemental change to it in the r cap direction. So there is no other direction in here, so it's just dr, that's the change in the r cap direction. So for in the phi cap direction, you can see d phi, the arc length will be r times d phi, so that will be the change in the phi cap direction. So in the z cap direction, there is no phi dependence or r dependence, so it's just a solid disk, so it will be dz, right. So these are the changes in the z cap, r cap, z cap, and phi cap directions for cylindrical system. So let's look at dv. dv is just multiplication of all this, that is dr r d phi dz. So r dr d phi dz is the dv, elemental volume change, right. Now let's have a look at the area element of this thing, right. So area element, to consider the area element, you have to construct a cylinder. A cylinder will have three surfaces: the first top circular and bottom circular and the curved surface. First surface is the curved surface, second is the top circular, and third is the bottom circular in the negative z cap direction. So the area element for the first surface is dA must be equal to what, r dz d phi in the r cap direction, right. And so r is a constant here, right, the radius is a constant for the first surface, and for the second surface dA must be z is a constant, right, z is a constant. So that means that dA must be equal to what, r dr d phi in the z cap direction, right, in this z cap direction. So the top r is what, a constant, r is a constant here, right, and for the second it is r is varying, right, radius is varying, and for the third surface also dA must be equal to negative of that, because in the negative z cap direction r dr d phi in the z cap direction. Oh, this is in the r cap direction, sorry about that. So that's how you find out the area elements. Now let's construct a cylinder centered at the origin, right, half of the cylinder centered at the origin. So for that, let's take our coordinate system x, y, and z, right. Let's take down that x, y, and z axis. You can see that you have to move from the origin to the x axis, right, in the r cap direction, 0 to r for the first part construction, 0 to r, and then you move around in a 0 to 2 pi in the phi axis, right, phi cap direction, and you form a disk, right, r from 0 to r, and then the phi cap direction you move from 0 to 2 pi. And then in the z cap direction you move from minus L by 2 to L by 2. So you have to move downwards and upwards at the same time. So you have a complete cylinder just like that, okay, centered at the origin, and all the elements, other elements, right, from minus L by 2 to plus L by 2, all the other elements will be the same, area, volume, all be the same as the last time. Now let's construct a quarter of a circle of a cylinder, right, a quarter of a cylinder. So for that, you can see the quarter of a cylinder is just 1/4 the part of a cylinder. You have to divide the cylinder into 4 halves, and 1/4 the part of a cylinder will be there. So now for that, you can see, you can use the coordinate system x, y, z again, and x, y, z axes right there. And what you can do first is that you have to move in the r cap direction from 0 to r, which is a radius, and you move from 0 to r, and then you move in the phi cap direction from 0 to pi by 2, which is 1/4 the part of a circle, right. And then in the z cap direction you move from 0 to L to complete the cylinder, and then you will have 1/4 the part of a cylinder right there. So that's the 1/4 the part of a cylinder. Now what we can do is that we can go for we have 5 surfaces actually, and the first surface will be the outer common surface, the second surface will and third surface will be in the z cap direction, and the fourth and fifth surface will be in the phi cap direction, right. So the first surface dA will be what, dA will be r d phi dz in the r cap direction, and for the second surface dA will be equal to what second surface is, for that the z is equal to 0, right, z is equal to 0, so it will be minus r dr d phi in the negative z cap direction. So for the third surface it will be what, Z will be equal to L, so dA must be equal to R dr d phi in the z cap direction for the force surface, right? For the force surface, phi is equal to 0, right? Phi equal to 0, so dA must be equal to what? Minus dr dz in the phi cap direction, negative phi cap. For the fifth surface, dA must be equal to dr dz in the positive z cap phi cap direction. So that's how we complete the cylindrical coordinate system. And for more videos, you get to this consciousness physics channel. All the best for you guys, and please like and subscribe and share, please.